Today, I will talk about the basic points of ventilation systems. This time, I will explain the basic matters of ventilation systems and ventilation calculation, based on some calculation examples. I am going to talk based on the content shown on the slides. Introduction. 1. Purposes of ventilation. The general purpose of ventilation is the dilution or elimination of unnecessary things in the air to meet certain conditions, including the room environmental standards. Particularly, the following purposes are included. 1. Purification of the room air. To exhaust pollutants generated by room pollution sources to the outside of rooms, and to maintain the good condition of the room air environment by supplying fresh air from the outside of the room. 2. Elimination of heat. To remove the heat generated by machine rooms in the machinery in factories, and that generated by cooking equipment in kitchens. 3. Supply of oxygen. To supply oxygen required for residents and the combustion of burning appliances. 4. Elimination of steam. To exhaust the steam generated in rooms and humid air to the outside of rooms. Generally, ventilation has not only one purpose. The purposes of ventilation in the room include, for example, purification of the air, removal of heat, and the supplying of oxygen. 2. Systems and classification of ventilation. The ventilation systems are roughly classified into two systems. Mechanical ventilation systems use the power of machines, including fans. Natural ventilation systems use air buoyancy. In other words, natural ventilation systems use the difference of air densities of different points of the natural wind or those of the airflow caused by the difference of temperatures between the inside and outside of the building. Mechanical ventilation systems are roughly classified into three classes as shown on the slide based on where fans are installed. For Class 1 ventilation systems, both air supply fans and exhaust fans are installed. For Class 2 ventilation systems, only air supply fans are installed. For Class 3 ventilation systems, only exhaust fans are installed. As an example of one of the natural ventilation systems, a system using the updraft caused by a difference in temperature is shown on this slide. Mechanical ventilation systems are roughly classified into two systems. General ventilation systems dilute the room pollutant density by replacing the room air with outdoor air. The local ventilation system ventilates the air from where pollutants are generated. If a pollutant source is not in a specific place, a general ventilation system is applied. This system is adopted in places including the room. If a pollutant source is identified, a local ventilation system is applied. This system is adopted in rooms, kitchens, laboratories, and restrooms. In the case of a general ventilation system, basically pollutants generated in rooms are diluted and diffused. Depending on the type and quantity of the generated pollutant, a large quantity of air must be ventilated. On the other hand, Local ventilation systems can pick up pollutants near a pollution source. Therefore, room environment conditions around the source are not so affected. In addition, less air is needed to be ventilated. Three, ventilation efficiency. 1. Concept. Ventilation is required for the supply of fresh air, good maintenance of air environment, and the effective removal of as much pollutants as possible. If the air in a space is completely mixed with pollutants, the density of the pollutants in the whole space is uniform. In addition, the density is equal to the exhaust concentration. Actually, however, complete mixing rarely happens. An extreme case of a short circuit is shown on the slide. The quantities of pollutants generated in two examples are equal. In addition, exhaust concentrations in two examples are also equal. The mean concentrations between the rooms in the examples, however, are very different depending on where pollutants are generated. In such a case, a standard is needed to measure how pollutants can be removed by ventilation systems. Two, ventilation efficiency indexes. Ventilation efficiency indexes used for evaluation of ventilation performance include the following factors. 1. Age of the air. 2. Air ventilation efficiency. 3. Pollutant removal efficiency. 1. Age of the air. Path between the time when the air is supplied from the outlet into the room and the time when it is inhaled into the inlet are conceptually shown on the slide. As shown on the slide, a part of the air supplied in the room may be bypassed. In addition, a part of the air may stay for a long time in the room. The age of the local air means the average time it takes for the air to move from the outlet to an optional point, P, in the room. Residual life means the time it takes for the air to move from an optional point to the inlet. Lifetime or residence time means the time it takes for the air to move from the outlet to the inlet. Two. Air ventilation efficiency. The air ventilation efficiency is a measure to indicate how fast the room air is ventilated. Under the same ventilation air quantity, the real ventilation time is compared to the theoretically shortest ventilation time. When the air is changed using a piston flow system, the air is ventilated for the shortest time. The piston flow system continuously pushes air in the same way as objects are pushed by a piston device. In other words, the air comes from one end of the room, passes through the room linearly, and at last reaches the other end of the room. When a piston flow system is used, the air ventilation time is equal to the theoretically shortest air exchange time. Based on the four different airflow types, the air ventilation efficiencies are classified as shown in the table. I will explain the displacement ventilation system shown in the lower left drawing. The displacement ventilation system uses the ventilation power caused by the difference of temperatures of the air. It is like a combination of a natural ventilation system and a mechanical ventilation system. As shown on the slide, when the air at a temperature lower than the room temperature is supplied from the level of the floor, the air is heated by heating elements in the room. As a result, updraft is generated. Dust and gas generated by pollution sources are carried towards the ceiling by using the power generated by this current of air. The displacement ventilation system is intended to maintain the environment of residence areas by exhausting the air from the height of the ceiling. Theoretically, the displacement ventilation system is more similar to the system using a piston flow rather than the system using completely mixed air. Higher ventilation efficiency, therefore, is provided. Three, pollutant removal efficiency. The pollutant removal efficiency is a measure used to indicate how fast pollutants in the air are removed from the room. This efficiency is defined by the ratio of the density of stable pollutants exhausted to the average density of stable pollutants in the air. Based on three different types of air flows, pollutant removal efficiencies are shown on this slide. The efficiency for completely mixed air is 1. Two, ventilation design. 1. Factors involved in ventilation. Factors involved in ventilation are different depending on whether subjects are people or objects. If people are the subjects in the room, the main factors involved in ventilation are as follows. 1. Oxygen. 2. Bad smell, cigarette smoke, etc. 3. Heat. 4. Moisture. 5. Suspended particulates. 6. Poisonous gas, including carbon dioxide, carbon monoxide, nitrogen oxide, and sulfur oxide. 7. Formaldehyde. What rooms are used and what factors are involved in individual rooms are shown in the table on the slide. Two, room standards and installation standards. 1. Room environmental standards. Based on a law, room environmental standards are shown on this slide. 2. Ventilation system installation standards based on the Building Standards Act. Under the Building Standards Act, ventilation systems must be installed in rooms as shown on this slide. 1. Calculation of ventilation air quantity for rooms. The ventilation air quantity for rooms is calculated by an equation as shown on this slide. The Building Standards Act requires the quantity of ventilation to be 20 cubic meters per person. The standard for building facility design established by the Ministry of Land, Infrastructure, Transport and Tourism is 30 cubic meters per person. Two, calculation of ventilation air quantity for rooms where fire is used. Requirements for calculation of ventilation air quantities for rooms where fire is used, including kitchens, are stipulated in the public notice on specifying methods of structural ventilation systems. The summary of them is shown on the slide. Constants to be used for the calculation formula are predetermined, based on the installation of equipment including ventilation fans and hoods. The requirements are classified in the list on the slide. Hoods are classified in the table. You should notice that constants are different based on factors including the dimensions of individual hoods. Three, Calculation of ventilation air quantity based on permissible values and standard values. You should calculate ventilation air quantities which are required to meet standard values. Calculation formulas needed to do so are shown in the table. I will explain calculation examples for various ventilation types in the section of ventilation calculation examples. So, here, I will explain how to determine ventilation air quantities of carbon dioxide and dust. One. Ventilation air quantity calculation based on the carbon dioxide concentration. Sample exercise. Determine the ventilation air quantity needed when 100 people are in the office. Assumed conditions are shown on the slide. The calculation formula to determine the necessary ventilation air quantity based on carbon dioxide is shown in the table. The quantity M of generated carbon dioxide is shown on the slide. In addition, the allowable concentration and the carbon dioxide concentration of the outdoor air are obtained like this depending on certain conditions. If you insert the required numeric values into the calculation formula and calculate it, you get the results shown on the slide. 2. Ventilation air quantity calculation based on raised dust amounts. Sample exercise. Determine the necessary ventilation air quantity for the office, assuming conditions shown on the slide. This is a calculation formula to determine the necessary ventilation air quantity based on the generated dust amount. The generated dust amount M is determined in this way. In addition, the allowable raised dust amount and the quantity of dust of the outdoor air are shown on the slide based on certain conditions. If you insert those values into the calculation formulas and calculate it, you obtain the results shown on the slide. If you want to determine the ventilation air quantity, you should calculate the ventilation air quantity based on all factors involved in ventilation. The maximum ventilation air quantity is the ventilation air quantity of the room to be ventilated. Three. Ductless ventilation systems. A large quantity of air must be ventilated to treat exhaust gas in large spaces, including large-scale underground parking lots. Fresh outdoor air must be distributed to every corner of parking lots. Of course, larger and longer ducts are required. If the size of the ducts is larger, a greater story height is needed to secure the effective dimensions of the ducts. These conditions have a direct influence on costs. Induced ventilation systems may be used for large spaces. If so, intermediate ducts are removed. Required apparatuses are locally positioned at the required positions. As the air is blown at a high speed, neighboring air is induced and sent. As a result, the overall ventilation efficiency is higher. In the drawing on the slide, one example of the induced ventilation systems is shown. Takei Shaw offers ductless ventilation systems. Ductless ventilation fans can discharge fast air flows. They induce the air around themselves. Such fans can therefore be used for ventilation and air conditioning. They are best used for the ductless ventilation of parking lots and the air conditioning of large-scale places like factories, halls, and gymnasiums. Induced draft fans manufactured by Taniyama, Incorporated, one of our group companies are used. This slide shows one example of a ductless ventilation system used in a parking lot, where air fuse fans are used. The air supply area is shown on the right side on this slide, while the exhaust area is shown on the lower left side on this slide. Air fuse fans are set up between the two areas. The fans induce the air in the air supply area to send it to the exhaust area. Thus, systems as shown on the slide do not have intermediate ducts. 3. Example of ventilation calculation. 1. Calculation of general ventilation. The first example is a calculation example for general ventilation of a room. The ventilation amount is determined based on the ventilation rate. Multiply the cubic capacity of the room by the ventilation rate. As shown on the previous slide, the ventilation rate is variable to an extent. For rooms such as restrooms, consider where the system should be placed and other conditions. If the system is likely to be used more frequently, increase the ventilation rate. For example, the ventilation rate should be increased if you expect the usage frequency of a restroom in a commercial building to be high. The ventilation rate of a restroom ranges from 5 times to 15 times. Select, however, the more frequent 15 times of the ventilation rate and calculate the ventilation air quantity using it. 2. Ventilation air quantity of a room where fire is used. When you perform the calculations to be shown on an upcoming slide to determine the ventilation air quantity of a kitchen, the following must be calculated. 1. The calculation of ventilation air quantity based on the shape of the hood according to the Building Standards Act. 2. The calculation using the minimum phase velocity which is needed to collect smoke by using a hood. 3. The calculation using the ventilation rate. Let's determine the ventilation air quantity by calculating factors number 1 to 3 in order. The ventilation air quantity to satisfy all 3 factors is the maximum numeric value. The ventilation air quantity is, therefore, 7,800 cubic meters. Ventilation air quantity for kitchens using electrical appliances. Ventilation systems are installed as a result of calculations based on the following factors. No standards of ventilation air quantity are established for the purpose of restriction of combustion gas discharged by electrical kitchen appliances in any laws or regulations. 1. Electric capacity of electrical appliances in the kitchen. 2. Phase velocity around the hoods. 3. Ventilation rates. The ventilation air quantity determined by a ventilation rate is a rough indication of the ventilation air quantities for general housing. Supply air rates for kitchens. So far, I have explained the calculation of exhaust flow rates for kitchens. One point to pay attention to is to ensure that bad smells from a kitchen do not flow out to spaces including dining rooms. So, set a negative pressure in the kitchen. If the negative pressure is too large, dirty air enters the kitchen. Determine a rough indication using the exhaust flow rate as a standard. Note that you should set the exhaust flow rate to about 10 to 15% higher than the supply air rate. 3. Ventilation for heat source machine rooms and electric rooms. Ventilation of the heat source machine room, including boiler rooms where burning appliances are installed. Determine the ventilation air quality of the machine room where burning appliances, including a boiler and a cold and hot water direct firing absorption generator, should be installed by considering the following points. 1. Secure the amount of combustible air that is needed for combustion. 2. The temperature in the machine room should not exceed allowable temperature. Now, I am going to explain some examples of calculation formats extracted from the Guide for Preparation of Design Calculation Formats published by the Ministry of Land, Infrastructure, Transport and Tourism. Here is an example of ventilation calculation for a room with cold and hot water generators. Let's calculate the supply air rate using calculation formula. A. Calculate the heat release generated by the main body of the equipment and the radiation amount generated by the flue. Calculate the heat release generated by the main body of the equipment based on the rated output of the equipment. Depending on the type of equipment, set the heat release amount at approximately 0.5 to 2% of the rated output. Calculate the heat release generated by the flue by calculating the flue duct area in the room and the difference between the exhaust gas temperature and the room temperature. If there are other objects which generated heat in the machine room, those calorific values are also added. Using calculated calorific values for the machine room, calculate the ventilation air quantity so that the temperature to be generated is below the allowable maximum temperature. Calculate the required air quantity using the consumption heating value of the equipment. The equipment shown on the slide uses kerosene as fuel oil. Calculate consumption heat capacity using the fuel consumption, the fuel density, and the lower calorific value of the equipment. Next, multiply the consumption heat capacity by the coefficient based on required air quantity. For gaseous fuel and liquid fuel, as a coefficient based on air quantity required, use 1.204 cubic meters per hour per 1 kilowatt of consumption heat capacity. The supply air rate is over the sum of the ventilation air quantity to maintain machine rooms at the allowable temperature and to maintain the air quantity needed for combustion. The exhaust air quality is the difference calculated by subtracting the air quantity needed for combustion from the supply air quality. Machine rooms where cogeneration system equipment is installed. Cogeneration system equipment are burning appliances like boilers and cold and hot water direct firing absorption generators. Therefore, consider the following points and determine the ventilation air quantity. Let's calculate the supply air rate using calculation formula A. Here, V1 is the ventilation air quantity to maintain a room at allowable temperature. V2 is the amount of combustible air required for equipment. Calculate the heat release based on the fuel consumption of the equipment and the rated output of the electric power generator. Using the result, calculate the ventilation air quantity. Calculate the required amount of combustible air based on the fuel consumption and the combustion amount of theoretical combustion air of the fuel oil. This is an example of a calculation where numeric values shown on the slide were used to calculate the ventilation air quantity for gas engine type cogeneration system equipment. Calculate heat release generated by the equipment based on the fuel consumption and the rated output of the electric power generator, and calculate the ventilation air quantity. Based on the fuel consumption and the fuel, calculate the air quantity required for combustion, using the amount of theoretical combustion air and the excess air ratio. The excess air ratio is different depending on conditions including the way of combustion. When you carry out calculation, you should confirm the ratio by contacting the relevant manufacturer. The supply air quantity is higher than the total of the ventilation air quality maintained at the allowable temperature for machine rooms, and the air quantity required for combustion. The exhaust air quantity is determined by subtracting the air quantity needed for combustion from the supply air quantity. Refrigerated machine rooms. Select the high value as the ventilation air quantity for the refrigerated machine rooms, which is between the ventilation air quantity shown in the legal refrigeration capacity in tons and the ventilation air quantity calculated in the ventilation rate. If the legal refrigeration capacity is used, calculation formulas to be used based on refrigerating capacity are different. Use a calculation formula suitable for the planned refrigerating capacity. To confirm the legal refrigeration capacity, refer to the relevant catalog, ask the manufacturer, or look it up using other ways. For the calculation formula shown on the slide, a basic case is assumed. If you calculate specifically, you should confirm which calculation formula should be used after consulting with a person in charge of high-pressure gas at the individual local government office. In the case of Japan, local governments mean the Tokyo metropolis government and other prefectural governments. The legal refrigeration capacity for the example shown on this slide is 150 tons. Calculate the ventilation rate. For the ventilation air quantity, adopt a higher value. Electric rooms. Determine the ventilation air quantity for electric rooms based on the calorific value obtained from the equipment including transformers and the allowable room temperature. Obtain the calorific value of the transformer from a person in charge of the electric system design. If you roughly estimate the ventilation air quantity, calculate the calorific value by the calculation formula shown on the slide. You should confirm the calorific value after you have determined the individual specific numeric values. Generator rooms. If you calculate the ventilation air quantity for generator rooms, in the same way as calculating that for rooms with burning appliances including boilers, consider the following points. Let's calculate the supply air rate using calculation formula A. Numeric values used in the calculation are those within the yellow frame. Obtain the calorific value of the electric power generator from a person in charge of the electric equipment. If you roughly estimate the ventilation air quantity, calculate the calorific value by the calculation formula shown on the slide. You should confirm the calorific value after you have determined the individual specific numeric values. Confirm the required amount of combustible air from a person in charge of the electric equipment or the manufacturer. The calculation formula to use is as shown on the slide. If you calculate, please calculate according to the specifications of the electric power generator. The supply air rate is over the sum of the ventilation air quantity to maintain machine rooms at the allowable temperature and to maintain the air quantity needed for combustion. The exhaust air quantity is the airflow determined by subtracting the airflow quantity needed for combustion from the supply air quantity. Elevator machine rooms. To determine the ventilation air quantity for elevator machine rooms, calculate the calorific value in the machine room and set the ventilation air quantity to maintain the allowable maximum temperature. On the slide, a calculation example for a rooftop elevator is shown. Within the yellow frame on the right side, numeric values used in the calculation are described. Confirm the calorific value of the elevator equipment from the person in charge of its design or the manufacturer. The calculation formula is as shown on the slide. Individual numeric values are those used for ventilation calculation for the elevator. Four. Ventilation calculation based on standard values. Calculation where CO2 density is adopted as the standard value. Here is an example of the ventilation calculation where CO2 density is adopted as the standard. However, even if you adopt another material as the standard, you should calculate it in the same way. Calculate the ventilation air quantity using the quantity of the material in the room and the allowable concentration. The calculation formula and an example of calculation are shown on the slide. The numeric value shown on the slide, based on the labor intensity, is adopted for the quantity of generated CO2 for its design. Calculation based on temperature and relative humidity standards. Here, calculation examples based on allowable temperature and allowable humidity are shown. Calculate the ventilation air quantity using the sensible heat generated in a room and the difference between the room allowable temperature and the outside air temperature in the room. The method of the calculation is the same as the cases where the ventilation air quantity required for allowable temperature is calculated, as previously explained. Calculate the allowable humidity using the quantity of room steam generation and the difference between the maximum allowable room absolute humidity and the absolute outdoor air humidity. This is the end of the explanation about basic points and calculation examples of ventilation systems.